Hello, everybody. Welcome to Mr. Colodi's extra lesson on summation notation from location unknown on a Friday. Maybe I should or should not be in school right now, but whatever, I'm here. So anyway, I am going to talk to you about summation notation because this is not a long lesson. And I'll get off screen right now. Actually, I'll get off screen in just a second, but there's going to be a time where you're going to be interested not in individual pieces of data, but rather a sum. And I made an example and you can see it. I wrote person and I wrote weight. Imagine you are on an elevator. Now, I don't know if you're like me, but when I get on an elevator, one of the first things I do when it starts to get crowded is I look at the little sign, maybe right above where you can press the buttons, and it says maximum weight capacity. And that's what I look at. So let me come off screen right now. Let's suppose one person weighs 140 pounds, another person weighs 210, another person weighs 95 pounds, another person weighs 135, another person weighs 160. Now, I'll tell you what, if I'm on that elevator, I don't give a hoot that person number 2 weighs 210. I just give a hoot that the maximum weight isn't above, so let's say 1,500 pounds, and I get stuck on that elevator. That's the concept of summing things up. Okay, so what is summation notation? It is just shorthand notation, and it begins with the capital Greek letter sigma. This is the capital Greek letter sigma. If you don't recognize it, just wait till you get to college. You'll see it as you go down fraternity and sorority row. Don't worry. Okay, now, this is sigma, but it's also called the summation symbol. Every summation symbol will have a lower limit of summation and an upper limit of summation. So this is called the lower limit. And this is called the upper limit of summation. And what are you summing up? Let's say you're summing up something like this, x sub j. Now, what on earth does that mean? What does this possibly mean right here? Well, it just means this. It just means that, honestly, Algebra 1 stuff, I am starting by plugging in, plug it in, the lower number that you see right here. So I'll start by saying x sub 1. And then it's called summation because you are adding. And then integer by integer, you will add the next integer, so x sub 2. And then plus x sub 3. And you will keep going until you get to the upper limit. So then plus x sub 4, and then finally plus x sub 5. And that's it. You might think, well, what the heck have we just done? Well, this is the shorthand notation right here of this longer sum. And it doesn't seem like a big deal, but what if this was the sum as j goes from 1 up to 30? And that's how you read this, by the way. The sum as j goes from 1 up to 5 of x sub j. And ladies and gentlemen, I'm going to present to you 5 rules of summation, and I am going to give you rule number 1 right now. Okay, rule number 1, which we just discovered. The sum in general as j goes from 1 up to n of x sub j is just x sub 1 plus x sub 2 plus ... all the way up to x sub n. There is rule 1 of summation. 4 more rules left. Let's go. Now, I can also take the sum of multiple terms. So what if I want to take the sum, let's say as j goes from 1 up to 3, of x sub j times y sub j. Does anything change? Absolutely not. That's just x sub 1, y sub 1, plus x sub 2, y sub 2, plus x sub 3 times y sub 3. So in general, ladies and gentlemen, I present to you rule number 2 of summation. Some might call it the product rule. The sum as j goes from, let's say, 1 to n of x sub j times y sub j is just x1, y1 plus x sub 2, y sub 2 plus ... plus x sub n times y sub n. By the way, are we restricted to only the product of 2 terms? No. You could take x sub j, y sub j, z sub j. you can do as many terms as you desire, multiplying together. So rule number 2 is about multiplying terms and then summing them up. Let's now talk about this. So until now, we've only dealt with variables. But what if one of these variables was a constant? Let's just suppose that all of these y's were the number 4. Okay, so let me just write this down. What if I say, I'm going to write this example right here. This is example, I'm sorry, I'm going to scroll back up. This was example 1. Let me now make example 2. This should have been example 2. Sorry, I know. This could have been example 1 right here. So then they're in line. Example 1, rule 1. Example 2, rule 2. Sorry, I'm making this up as I go. Example number 3 will line up with rule number 3. Get what I'm saying? Okay, so what if I say the sum as, let's say j goes from 1 up to 5 of, instead of y, I'll say 4 times x sub j, right? So then if I follow the rules from rule number 2, that's going to be 4 times x sub 1 plus 4 times x sub 2 plus 4 times x sub 3, I'm running out of breath, plus 4 times x sub 4 plus 4 times x sub 5. Woo! That's a lot. Why do I have to write 4 that many times? That's redundant. Why don't I just do 4 and then x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 plus x sub 5. But wait a minute. This piece, can't this be condensed into a summation symbol? It sure can. That could be 4 and then times the sum, what, as j goes from 1 to 5 of x sub j. Isn't that what this shorthand notation is? Right. But wait a minute. How did we get from here to here? What happened to the 4? Dun, dun, dun. Didn't the 4 just go from after the sum to before the sum? It did. Ladies and gentlemen, I present to you rule number 3. Rule number 3 is that if you take the sum, let's say j goes from 1 to n, of a constant, let's say a times x sub j. The rule is that that constant can go outside or before the sum. And then you're just left with this sum right here after. I'm not going to expand it out because we did that in rule number 1. Boom. 3 rules down, 2 to go. Okay, I'll do 2 more examples and then I'll go through some examples with you. All right, so now we've done an example where one of the variables was constant. What if all of the variables were constants? In other words, let's suppose, I'll say now, let's suppose that all of the x sub j's, all of them, just equal 1. So if I were to take this example right here and bring it down, I would be left with 4, and then I'd be 1 plus 1 plus 1 plus 1 plus 1. Right? You would agree? And so that would be 4 times 5, which is 20. But I want you to think about what we just did right there. Okay? That would be, and x sub j is just 1, so that would just be the sum as j goes from 1 to 5 of 4, because it's really just, if I take this and bring it down here, it's just 4 times 1. So what did I do to get from here to there? All that I did was I took the constant and I multiplied it by, wait for it, the upper limit, right? 4 times 5. That's right. I did it right there. That's it, ladies and gentlemen. I know this seems a little weird. I have a whole bunch of arrows going on here, and it does go a little smoother in person, but I bring you to rule number 4. And I'll call this example 4. So rule 4 is that if I take, let me erase that. That's kind of yucky right there. Boom, boom, there we go. If I take the sum as j goes from 1 to n of just a constant, just like the number 4, then my answer is just that constant multiplied by the upper limit. Ladies and gentlemen, I present to you rule number 4. Last but not least, one more rule and some examples. Okay, so let me write example 5 here, so I'm finally on board with this. Okay, we've taken a sum of a lot of things, some of an individual variable, some of the product of variables, some of a constant in a variable, some of just a constant, but we haven't taken the sum of a sum. So what if I said the sum, oh, and by the way, you don't always have to use j. You could say k, you could say any letter you want. It doesn't matter what letter you use. And so if I say the sum is k goes from 1 of x sub k plus y sub k, well, nothing differs here. I'm just going to do x sub 1 plus y sub 1 plus x sub 2 plus y sub 2 plus x sub 3 plus y sub 3. Done. But wait, I don't like this. I don't like all the parentheses. Since we're adding everything, we don't need these parentheses, do we? Can we reconfigure so that all of the x's are together? Sure we can. And can we reconfigure so that all of the y's are together? Y sub 1 plus y sub 2 plus y sub 3? Sure we can. But wait a minute. Isn't the shorthand way to write these x's the sum as k goes from 1 to 3 of x sub k? Yeah, it is. And isn't this shorthand just the sum as k goes from 1 to 3 of y sub k? It sure is. How do you like them apples? So wait, we went from here to here. And how did we do that? That kind of looks like distributing, doesn't it? It looks like distributing right through that parenthesis, and that's exactly what rule number 5 is. Rule number 5, the final rule of summation that we're going to deal with, is if you take the sum, I'll go back to j, as j goes from 1 up to n, just for consistency, of x sub j plus y sub j. And you could just distribute, and you'll get the sum as j goes from 1 to n of x sub j plus the sum as j goes from 1 up to n of y sub j. And boom, I give you rule numero 5. All right, so I'm going to give 4 examples right now and then call it a lesson using these 5 rules of summation. Okay, and I'm not going to necessarily go back, but you can go back and pause and look at the rules as I go through. So the first set of directions are to simplify using summation notation. Okay, example number 1. The sum, let's say, as j goes from 1 to 6 of 3 times x sub j plus 2 times y sub j. All right, so what does this mean, simplify using summation notation? It means to use these 5 rules of summation to simplify this down. All right, so let's do that right now. First thing, I see that we're taking the sum of a sum. So I could take the sum of 3 times x sub j plus the sum of 2 times y sub j. What did I just use? I just used rule number 5, didn't I? I distributed the sums to each one particularly. Now notice I didn't write the 1 and the 6 right just yet, because I'm going to keep this in summation notation. Now, what if I used rule number, let me see, I'm going to write this, rule 5. Then, couldn't I use rule number 3 to bring these numbers out of the front? I sure can. So it would be 3 times the sum of x sub j plus 2 times the sum of y sub j. Now, ladies and gentlemen, I know it doesn't seem like we've done a whole lot of everything, but that's actually the final answer. We've simplified the problem as far as we could while still keeping the problem in summation notation. That's it. That's all that the directions asked us to do. Mr. Colodi, do I have to write the j equals 1 up to 6 for each one? You don't have to, because you're not going to be expanding the problem out. Okay? So let me do one more with you of simplifying. How about the sum as j goes from 1 up to 4 of 2 times x sub j minus 5 times y sub j z sub j plus 6. Okay? All right, so with that said, I need to work this out. So first and foremost, I'm going to do two things at once, if you don't mind. I'm going to distribute, and I'm going to bring the constants out in front. So I'm going to do 2 times the sum of x sub j. Oh, I'm sorry, minus, that's a minus there. Good thing for the eraser. Minus 5 times the sum of y sub j, z sub j, plus the sum going up to 4 of 6. Yes, did you notice the only place where I wrote the upper limit is in this last term? Why? Because what rule is that of summation? Isn't that rule number 4? Whenever you take the sum of a constant, you need to multiply that constant by the upper limit. So my final answer is going to be 2 times the sum of x sub j. Oh my gosh, x sub j. I don't know why I keep writing just j. Sorry. Ooh, what just happened there? Whoa, 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 whoa. Let's go back. Let's see if I can erase what I did right there. Whoa. Let's keep going back. It looks like I did a whole bunch of stuff. There we go. I think I've now fixed the problem. Hang on. Working on it, working on it. Whew. I think I finally fixed it. I don't know what I just did right there. All right, let me just erase. 2 times the sum of x sub j. Whew. I thought I just messed up the whole thing. 2 y sub j, z sub j, plus 4 times 6, which is 24. That's it. Sorry, that was an extra like 45 seconds added onto the video for me just panicking for a moment. Okay, so there are 2 examples of simplifying. You're going to see those examples on your homework and or a test. All right, next, my last set of examples, 2 more examples, are evaluate. Now we're actually going to get a numerical answer. So example number 1, we're going to find the sum as j goes from 1 up to 5 of 3 times x sub j plus 2. And I want us to evaluate this if it is known that the sum of x sub j equals 10. All right, first, rules of summation. Why don't we distribute this? Pew, pew. Let's distribute that and bring the number to the outside. So it's going to be 3 times the sum of x sub j plus the sum going up to 5 of 2. Notice how I wrote the upper limit for the 2 again, because I'm going to multiply them. But wait, doesn't the sum of x sub j equal 10? It does. So then this ends up just being 3 times 10 plus 5 times 2, which is also 10. And that's 30 plus 10, which is 40. I'm done. I have just evaluated this question. I got one more example to do with you. Example number 2. The sum as, let's say, j goes from 1 up to 4 of x sub j minus 1, that's a minus, not an equals, minus 1, quantity squared. Oh no! Yes, you're going to have to FOIL here. So why don't you start by FOILing? All right, so this ends up being, what, if I don't rewrite it, so it's going to be x squared sub j. And then minus, if I FOIL, you could FOIL it on your own, but it's going to be minus 2 x plus 1. That's what happens if you FOIL that right there. Now, I forgot to tell you, it is known that the sum of x sub j equals 6, and the sum of x squared sub j, that equals 6. I'm sorry. The sum of x sub j equals -2. I know, I'm sorry. I haven't done Zoom videos since June, so it's been a little while for me. All right, so we're going to take this piece right here and we're going to distribute it. So it's going to be the sum of x squared sub j minus 2 times the sum of x sub j plus the sum going up to 4 of 1. What did I do? I FOILed and then I distributed. Rule number 5 there. So I know what the sum of x squared sub j is. That's 6. I know what the sum of x sub j is. That's -2. So let's plug in and go. So it's going to be 6 minus 2 times -2 plus 4 times 1, which is 4. So -2 times -2 is +4. So that's going to be 6 plus 4 and then plus the final 4. And my final answer is 14. So, ladies and gentlemen, that's our lesson. What's your homework? Let me get to the homework right here. Okay? This is your only homework. It's a worksheet, nothing from the book. The first problem say to expand. So you're just doing, in this problem in particular, x plus 1 plus x plus 2 plus x plus, x sub 3, I'm sorry, plus x sub 4. Okay? For examples like number 2, you're contracting, you're writing it as a sum. So this would be the sum as j goes from 1 what? Up to 8 of x squared sub j. There's 2a. I did 1a with you, I did 2a with you. Number 3 is where there are often many questions. Okay? I'll do letter C with you. It says the sum of x times y. So what do I mean by the x's and the y's? Notice there are 4 x's here and there are 4 y's. So it's going to be the sum of x1 times y1 plus the sum of plus x2 times y2 plus, and you get the point now, x sub 3 times y sub 3 plus x sub 4 times y sub 4. And then you sum all that together. You're going to do that for all the values there using the x's and the y's. Last but not least, number 4 is exactly like what we just did, the final 2 examples. So I'm not going to do one with you. All right, so I hope this does help. And please feel free to ask questions if you have them. All right, we shall see you all later.